Hi, so for today we're going to talk about the cylindrical coordinates. This is still a part of our lesson about the electromagnetics. Okay, a very major subject in electronics engineering. Okay, so we're going to solve two problems, and then we're going to know in this video how to convert rectangular to cylindrical and from cylindrical coordinates to rectangular coordinates. So basically, okay, when we have rectangular coordinates in 3D, we have the x, y, and z. So we have x, y, z, that is for rectangular. And when we talk about the cylindrical, we have phi, theta, and then z. So we have the cylindrical. Okay. So basically, we can always convert the rectangular to cylindrical and vice versa using this formula. So if we are given a rectangular coordinates, we can convert it into cylindrical by the following formula. We have phi equals the square root of x squared plus y squared. Of course, the values of x, y, z must be given in order for us to convert it into cylindrical. And then we have the phi equals the arctan of the y all over x. And the z's are the same. Okay, just copy the z. So if we wish to convert from cylindrical coordinates phi, theta, and z to x, y, z, okay, we need to use this following formula. So to get x, that's simply phi cosine of rho cosine of phi. This should be phi. I'm talking about phi, not theta. Okay. So, sorry for that. So, we have, this is rho, and this is phi. Okay. This one, just like the notation in physics density, it's called rho, and this is phi. So, we have rho cosine of phi for x, and then for y, we have rho sine of phi. And then, as well as I have said a while ago, z's are the same. So, that is the formula that we're going to use. So let's try to solve some problems. So number one, given points A, we have x equals 2, y equals 3, z equals -1, and B, we have the rho equals 4, and then we have the phi equals -50 degrees. We have the z as 2. Find the distance from A to the origin. So what's the distance of the vector A to the origin? So for number one, we need to find the distance, okay, the vector of A to the origin. So our terminal point is the origin. So what are we going to do is still, first we have to find a vector from point A to the origin. So and that is, we know that, so the origin has coordinate 0, 0, 0. So that is our terminal point. So we have 0 minus the x component of the initial point, which is 2. And then we have ax. Then we have plus 0 minus 3 for the y. Then we have plus, we have 0 minus -1 of z. Okay? So that is what I'm trying to say. So we have -2ax minus 3ay plus a sub z, because minus times negative would be plus. Negative times negative would be plus. So in order for us, this is the vector, okay, from point A to the origin. Okay? So if we wish to know the distance of this point A to the origin, okay, we simply get the magnitude. Okay? So what would be the magnitude? That's the distance. That's the length of our vector. -2 squared plus -3 squared plus 1 squared. Okay? So this would be squared. Let me just rewrite. So that would be what? Square root of 14, or in terms of 3 decimals, so we have 3.742. Okay. So that must be our answer for letter A for number 1. So check. So you see, if we are asked to find the distance of a certain point to the origin, it's much better to use what? Rectangular coordinates. Okay. So letter B. Find the distance from point B, this is the point B in terms of cylindrical, to the origin. So, as I have said, it's more convenient to actually convert first the cylindrical point, okay, into what? Into rectangular point and then get the magnitude of it. Okay? So we are going to get the point B is actually rho equals 4 and then we have phi equals negative 50. This is negative 50. And then we have z equals 2. So we're going to convert this into rectangular. Take note that your calculator should be in terms of degree when you are converting these values. So we have cylindrical to rectangular. We're going to use this following formula. Okay, we're going to use the following formula. So to get x, we have rho cosine of phi. So that is 4 cosine of negative 50. So our answer, if we calculate it in our calculator in 3 decimals, so that must be 2.571. So we have y, we have rho, sine of phi, we have 4 sine. So we're just going to change the cosine into sine of negative 50, and that must be negative 3.064. So this is our x, this is our 4. So z equals only to z, which is actually 2. Therefore, the coordinates of this point B in terms of rectangular coordinates, that is 2.571, then we have negative 3.064, and then we have 2. So we are asked to find the distance of that point to the origin. So again, we have to get the vector RBO from point B to the origin. So the origin is 0 minus 2.571 AX. Then we have plus 0 minus the negative 3.064 A sub Y. And then we have plus 0 minus 2 A sub C. So we have negative 2.571 AX. Okay, plus, this is negative times negative, that becomes plus 3.064 AY minus 2A sub C. Now, this is the vector, okay, stretching from the point B to the origin. So, how do we get the distance of that point to the origin? Just get the resultant or the magnitude. So, we have negative 2.571 squared plus we have 3.064 squared. Then we have plus negative 2 squared. So the answer in 4 decimal or 3 decimals, I mean, that should be 4.472. So that's the distance from the point B to the origin. Okay? Just as like what we did on the first one. Okay? So the last question for number 1 is the distance from A to B. So since we have what? Since we have both in terms of rectangular, this is point B, okay, and this is point A, okay, we have x2, y3, z sub equals 1. So we have x equals 2, y equals 3, and then we have z equals negative 1, if I'm not mistaken. That is negative 1. And point B, in terms of rectangular, so we have 2.571 minus negative 3.064, and then we have 2. So the distance from A to B, okay, is actually what? Oh, actually, we can use the distance formula. So, but first, that is still the same. We get the vector from A to B. So we have 2.571 minus 2, okay, for the x component, plus we have negative 3.064 minus 3 for the y component, okay, so that should be our y component, and then plus we have 2 minus negative 1 for the a sub c. So terminal point minus the initial point. In this case, we have AB. So we have 2 minus negative 1. So be careful with the sign and the direction of the initial point to the final point. So we have 0.571 AX. We have negative 6.064 AY. then we have plus 3a sub c. So this is the vector stretching from points A to B. So to get the distance between them, we simply get the magnitude. Okay? So we have 0.571 squared plus negative 6.064 we have squared plus we have 3 squared. Okay? And if we get the magnitude of that, that would be 6.79. So that is the distance of point A and point P. So let's go now to number 2. Let me just copy the problem number 2 so that we'll be having a copy below. Oops. Okay. So in number 2, okay, we have to transform each the following vectors to cylindrical coordinates at the point specified. Okay. So we are going to get the 5ax at point P. We're going to transform each of the following vectors to cylindrical coordinates at the point specified. So we have a 5ax vector. We are going to transform it into cylindrical coordinate at the point given P, Q, and A. So for what are we going to do here is to take note, okay, of the important relationship of the dot products between the rectangular and the cylindrical. So we have a table for getting the dot product. It's very important to memorize this actually or familiarize yourself. So we have, for example, we have the A component or row component for the cylindrical, and then we have the phi component for the cylindrical, and then we have A sub C. So what are we going to do is that if we wish to get the cylindrical coordinates at a point specified, we have to remember the dot products. So this would be cosine of phi. Okay, let me just rewrite this. Cosine of phi, negative sine of phi. Then we have 0, 0, and 1. We have sine of phi. We have cosine of phi. And then we have 0, 0, 1. So what's the purpose of this? So for number letter A, okay, we are going to transform the vector 5ax at the point what? At the point P, which is a cylindrical coordinate. So we have rho 4, we have phi equals 120 degrees, okay, and we have z equals 2. So we're going to transform that vector at the point specified. So we're going to use the dot product. So this is important dot products. Dot products. When we are trying to get or transform a vector at a point specified. Okay? Important dot products for rect and cylindrical. Rectangular and cylindrical. Okay? So in order for us to answer this, let me just rewrite this. Uh, this should be 5ax. Okay. So what are we going to do is we're going to let, okay, a as our 5ax, vector 5ax. So what are we going to do is to get the components of A in terms of rho, because we are trying to find the cylindrical coordinates of this vector at the point rho, phi, and z. So we have A sub rho, then we have A sub phi, and then we have A sub z. So using this, what are we going to do is we're going to get the dot product of A and then a unit vector, okay, A sub phi, okay, A sub rho. And this one also A dotted by A sub phi, then A dotted by A sub z. So that is dot product, not multiplication. So the essence is that, okay, of this table above is that if we get the dot product of AX and, for example, A sub X and A sub rho, we need to evaluate the cosine of phi. Okay? So what we're going to do is that we have, since A is 5AX, that should be dotted by A sub rho. And since A is 5AX here, that this should be dotted by A sub phi. And since we have 5AX here all again, and then that is dotted by A sub Z. So what happens is that we have 5 A sub X dotted by A sub phi. Okay? And then we have 5 also A sub X dotted by A sub phi. We have 5 A sub X dot product by A sub C. We just factored out the 5. Okay? So what's the essence of this? So that's where the table gets into work. So we have A sub X dotted by A sub phi, or A sub rho, I mean, that would be 5 cosine of phi because of the table here. Oh, and for our phi, okay, so we have 5 A sub X multiplied by A sub phi. And that is what? Negative sine of phi. And of course, for the last one, we have A sub X multiplied by A sub Z. As you can see here, dotted by AX and dot product by AZ, that should be 0. So, what would be the value of phi? Cosine, that would be the value of the given points here. The phi of the given point, that is 120 degrees. Here we have 5 negative sine. This is still phi, so we have 120 degrees also. And of course, this would be 0. So upon evaluating 5, cosine of 120 degrees, that's negative 2.5. Okay, so meaning this is the phi, or this is the rho uh, in terms of cylindrical coordinates up of the point 5AX at this point. Okay, so evaluating A sub phi, okay, so we have what? If you input it into a calculator, we have negative 4.33, and of course, the A sub Z is 0. Hence, the point, okay, of the vector A in terms of, for example, that vector A is our answer, okay, is what? These are the components of the rho, phi, and z. Okay, that's the components. So we have negative 2.5 A sub rho, then minus 4.33 A sub phi. So this is now the transform of that 5AX at this point. Okay, at this given point, cylindrical coordinates. I hope you get that. That's the purpose of having this dot products. Okay, table of dot products. So for letter B, 5AX at Q equals X. So we have 5AX at X at Q. Let's say Q. Okay, at Q, X equals 3. Then we have Y equals 4. And then we have Z equals, what is that? Negative 1. So, as you can see here, the question is actually asking cylindrical coordinates. Okay? So, at letter B, since we are given a point Q that is in terms of rectangular, we need first to convert this Q into cylindrical. So, we have phi equals x squared plus y squared, the square root of that. Then we have phi. This is rho. Okay, this is rho. And we have phi, the arctan of y all over x. And then we have z equals still z. So, we get that. So, we have 3 squared plus 4 squared. Then we have 5. Okay? And this should be arctan of 4 over 3. That's y all over x. That is 53.13 degrees if you try it in your calculator. So z is still negative 1. So the point Q in terms of cylindrical coordinates would be 5. Okay, we have 53.13 degrees. And then we have negative 1. So this would be our rho. This would be our phi. And this would be our z. So again, following a while ago, the process, we are going to let what? A equals 5AX. So that we have to get A, what? A phi, sub phi. Then we're going A sub rho, I mean, and then we have A sub phi and A sub z. Using again the dot product. So we have 5, we have AX dotted by a what? Unit vector A sub phi. So we have 5 AX dotted by A sub phi. This is rho. I'm always I'm always confused, no? It's always raw. This is raw, okay? Please forgive me. This is raw, this is phi. So we have 5AX multiplied or dot product by A sub A. Okay. So you see, if we are going to go back in our we are going to go back in our table. So we have AX dotted by A sub rho would be cosine. Okay, cosine of phi. So this would be 5 cosine of phi. This would be 5 negative sine of phi a while ago. And this would be 5 multiplied by 0. Okay, so as you can see, A sub X and A sub Z, when we dot product them, we have get 0. So 5 times 0 would be 0. So again, so we have 5 cosine. The phi now is actually 53.13. So we have 53.13. And then we have 5 multiplied by negative sine of 53.13 degrees. Then we have 0 here. So evaluating this in our calculator, we have 3. For A sub phi, we have negative 4, and then we have 0. So hence, okay, hence, the point 5AX at the point Q here in terms of cylindrical coordinates should be 3A sub rho. Okay? And then we have minus 4A sub phi. So that would be the answer. Okay? If we are going to transform 5AX at this point Q in terms of cylindrical coordinates. Okay? So let me just copy this first. Copy the table. Oops. Okay, let's just copy that table for our point of reference. Okay. So for number 3, we have to find the transform the 4AX, okay? Transform the 4AX minus 2AY and minus 4AZ at point A, X equals 2, Y equals 3, Z equals 5. Of course, in terms of cylindrical. Okay? So we have for letter C, we have 4AX minus 2AY minus 4AZ at what? A equals X equals 2, Y equals 3, and Z equals 5. So this is a little bit long in terms of solution. So the first thing that we're going to do is to convert A in terms of cylindrical coordinates. So if we convert that, that would be 2 squared plus 3 squared. That is 3.61. So we have the phi, we have the arctan of y all over x, that is 3 halves. So we get 56.31 degrees. And for the z, that's equal to 5. So we have now the points A in terms of cylindrical. So we have 3.61. So we have phi equals 56.31 degrees. And then we have z equals 5. Okay? So now we can perform. So we are going to let A equals 4AX minus 2AY minus 4AZ. And then we're going to get again the A row, sub row, A sub phi, and A sub say. Okay? Of that. So we have what? We have A dotted by a unit vector of A sub rho. We have A dotted by a unit vector of A sub phi. We have the A dotted by a unit vector of A sub say. So what are we going to do with that? Of course, we have 4AX minus 2AY minus 4AZ and then dotted by A sub rho. Okay, so that is how we do that. So this would result into 4ax dotted by a rho minus 2a sub y dotted by a rho minus 4a sub z dotted by a rho. Okay, so again, we have here our values for the dot product of different rectangular coordinates and the cylindrical coordinates. So this is what we are going to refer to. Okay, and we're going to use the values of the phi here, okay, for our calculations. Okay, so let me just erase this first. Let me just erase this first. And we focus on a sub rho. So we have what? We now have 4 dot product by a sub x and a sub rho. That would be cosine of phi minus 2 dot product of a sub y and then a sub rho would be sine of phi minus 4 dot product of a sub z and a sub rho, okay, would be 0. So this would be 4 cosine. The phi here is the phi that we have solved a while ago. So we have 56.31 degrees minus 2 sine of 56. I'm sorry. So this would be 56.31 degrees. 2 sine of 56 minus 31 degrees minus 0, of course, because 4 times 0 would be 0. So if we evaluate this, okay, so our answer that we would get would be 0.555. That's only the term or the scalar quantity of the A sub rho. Okay, so let's try A sub phi, and again that is A dot product by a unit vector A sub phi. Let me just rewrite this below. So we have A sub phi, that we have A dotted by A sub phi. So that becomes 4ax minus 2ay minus 4az dotted by A sub phi. So what will happen is that we have 4a sub x dotted by A sub phi minus 2 a sub y dotted by A sub phi and then minus 4 a sub z dotted by A sub phi. So refer to the table for the dot product. So we have 4 ax, a sub x, and then a sub phi would be negative sine of phi. Okay? Then we have minus 2 a sub y, and then what? A sub phi is cosine phi on the table. Minus, we have a sub c dotted by a sub phi. So that is still 0. Minus 4 times 0. So we need to evaluate. We have 4 negative sine of 56.31 degrees minus 2 cosine of 56.31 degrees minus 0. So upon evaluating, we get the component of A sub phi, and that becomes negative 4.44. That's a component. And lastly, for A sub z, we have dot product of vector A and the unit vector A sub z. So we have 4a sub x minus 2ay minus 4a sub z dotted by unit vector A sub z. That becomes 4a sub x dotted by A sub z minus 2a sub y dotted by A sub z minus 4a sub z dotted by A sub z. So referring again to our table, so we have a sub x dotted by a sub z. So we have a sub x dotted by a sub z would be 0. Okay? That would be 0. So 4 times 0 minus 2 a sub y dotted by a sub z. A sub y dotted by a sub z is 0. That would be 0 also. Minus 4 a sub z dotted by itself. That product dotted by itself is 1. So we have, so we all know it's this obvious, 4 times 0 is 0, minus 2 times 0 is 0. So our a sub z would be negative 4. So our answer hence for this formula is that the cylindrical coordinates of that point at that specified point, okay, at that specified point A here would be what? Negative or 0.0555, that's the component of A rho, A sub rho. And then we have, this is A sub rho. Let me just rewrite. A sub rho minus, we have 4.44 A sub phi. Then we have 4 minus 4 A sub z. Okay? So this would be our answer. Okay guys, I hope you learned something new about our topic all about the cylindrical coordinates and how we convert those cylindrical coordinates into rectangular and vice versa, and how we get a specified vector at that specified point, okay, in terms of cylindrical coordinates. So if you find this video helpful, please don't forget to subscribe, and if you're new to my channel, please see my other videos about electromagnetics and other math and engineering courses. So thank you so much for listening. Again, this is Engineer Abat. God bless you.